Lesson 3.3, Basic Functions and Equations. This will correlate with Lesson 23. Big thing today is being able to look at a equation and have an idea of what the graph is going to look like. Now everything we're dealing with here is a function, so it would pass our vertical line test. A couple of vocabulary words that we'll just talk about. Origin, something that we've talked about before. Origin is point 0, 0. It's where your x and your y axis meet. You probably already know that. Next thing is talking about quadrants. Okay, the quadrants, know that there are 4 quadrants. Quadrant 1, 2, 3, and 4, and they go in that order there. Note that this side is plus plus. Basically what that means is your x and your y value are both positive. Minus plus meaning x is negative and y is positive. Minus minus is when you have x and y are both negative numbers in the ordered pair, and plus minus meaning your x is positive and your y is negative. A linear function. Now we've discussed what linear functions are. We're actually the beginning part of the unit. Basically a linear function is a straight line, and it can be written in the form y equals mx plus b, where m and b are constants and m is not 0. So remember when you graph these here, you could have y equals mx plus b, meaning m, your slope is positive, and you could also have a negative slope. Something that would look like this is this graph shown here. You have a linear line going here. That would be a positive slope, and obviously something like this would be a negative slope. But a linear function, note that if you did the vertical line test, it would pass the vertical line test because it intersects either graph in one spot. There's that vertical line test. Our next function that we're going to talk about is called a quadratic function. A quadratic function will have a U-shaped curve. That U-shaped curve is called a parabola. Okay? The parabola can curve up, it can curve down, but it's a smooth curve. The equation would look like something like this: y equals ax squared plus bx plus c. Biggest thing that you need to note here is that everything that revolves around these graphs today is based upon x. Okay? Your highest exponent is x squared. When x is squared, you're going to have a parabola or a quadratic function, whether that curve up or it curve down. Both are dependent upon your a value. If your a coefficient is positive, it curves up. If it's negative, it curves down. But if you see the highest exponent is squared, it's going to create a parabola or a smooth curve. The linear function, if you look up here, x right there is really x to the first power, so you have that linear function. When x is squared, you get that quadratic function. Next thing we'll talk about is a cubic function. The equation looks something similar to this right here: y equals ax cubed plus bx plus cx plus d. The biggest thing is when you see y equals x cubed, and cubed is the greatest exponent, your graph will look something similar to this. When x is cubed, it creates that function right there. And again, if you did a vertical line test, note that it would only intersect the graph in one spot. So when the highest exponent is cubed, that's the what the graph would look like. And obviously, if your a value here is positive or negative, that's going to determine the graph, but it'll still create something similar to that function there. Our next function is the absolute value function. So when you have x and the absolute values, when you see x is in that absolute value, you get a V-shaped graph. Now that graph can V-shape up, it can V-shape down, okay? But the big thing is it's a function again because it'll pass that vertical line test. Again, that's when x is in the absolute value. Next is called an exponential function. An exponential function, if you look up here, and everything revolves around x. When x is an exponent, you're going to get a graph that will look something similar to this. And something I want to make note of here, this never touches the x-axis. So it'll never touch the x-axis. And that happens when you have x as an exponent. So you get this nice, smooth curve, something similar to that. So it's an exponential function. Our next situation here, our next function is a radical function. A radical function, anytime you see x in a square root. So if you have the square root of x, your graph is going to create this nice curve right here. And one thing to note here is that inside your square root, it'll only be real numbers inside that square root, not negative. Okay, you cannot have a negative number inside that square root. You could go ahead and give it a shot on your calculator, and you'd see that you cannot get a negative number inside that square root. Just a little proof here. If you had, let's say, 6 and you had a negative 6 and you put that in a square root, you would see that you would have an invalid input. You're not able to put a negative number in that square root. That is why you cannot use square root there, or a negative number in our square root. So that is our radical function. Next is a reciprocal function. It's a function in the form of y equals 1 over x. So notice here, x is a denominator. When you have x as your denominator, this is what our graph would look like. And biggest thing here is on this graph, it'll never, your x value will never come to be 0. Okay, that'll go on in both directions there, not touch that line. You cannot have 0. The line will never touch 0. This x can't be 0. The reason why it can't be 0 is you can't divide by 0. But note, when you have x as a denominator, your graphs will look something similar to this. A conjecture is an opinion or theory used to express a guess or speculation. Basically, you might have heard of a hypothesis in science, very similar. Steps in graphing various functions. Now you'll be graphing all these different types of functions. Biggest thing is make that table. Once you make the table, you'll come up with plots. You'll plot them and you'll have an idea of what these graphs look like. The big thing is there's different ways that you can graph these. For instance, y equals mx plus b. We've dealt a lot with it. Well, we can use the slope-intercept form of graphing. We know that we can plot the b value, and then once you plot the b value, you can use your slope to get another point and graph it. I mean, that's old news. You can use that method. But when we get into some of these other methods, you'll need to set up a table that we aren't familiar with a shortcut how to graph yet, and we'll need to set up a table in order to graph. So basically, a little thing that you can write down here, these equations that we just basically discussed are all functions. If you were to graph them, they would all pass the vertical line test. Obviously, this one right here, this would be x to the first power. This would be a linear function. When x is squared, remember, we get that parabola, that U-shaped graph. Now, if you look on here, all of those, everything has to do with x. When x is cubed, we get a graph that looks like this. When x is an absolute value, you get the V-shaped graph. When you have the radical function, so you have it inside the square root, your graph will look something similar to this. And last, the reciprocal, when x is a denominator, that's where you'll get the graph that looks something similar to this. Okay, so all those would pass that vertical line test. Those are all functions, and the biggest thing that I just want you to understand is it's what is happening to x when it's to the first degree, second degree, third degree, absolute value inside a square root, or x is a denominator. It creates all these different types of graphs which are functions. So you should be easily able to look at an equation and have an idea of what shape that graph is going to look like. This concludes our lesson on lesson 3.3, lesson 23, basic functions and equations.